In today's video, we will learn about Markovnikov's rule and the mechanism of reaction between HBr and propene molecule following Markovnikov's rule. So the question that I have taken is, state Markovnikov's rule and write its mechanism for the addition of HBr with propene. Now state this Mr. Markovnikov was a Russian scientist. So he, through his observation, he gave a rule and which states that the negative part of the addendum, that is the adding molecule, gets attached to that double bonded carbon atom which possesses lesser number of hydrogen atom. So this will be clear. We have to explain this by taking the example of propene. So this is propene. Okay. Now HBr addition, HBr, see HBr, H has delta plus charge and Br has delta minus charge because Br is more electronegative. It states that the negative part, what I have written, the negative part. Now you can see it is the Br which is the negative part. So it states that the Br will add to that double bonded. Here this is the double bonded carbon atom. In this place the double bond is there. That means according to this rule, this Br will add to that carbon. See, 1, 2, there are 3 carbon. That carbon which has lesser number of hydrogen. Carbon 1 has 2 hydrogens, but carbon 2 has 1 hydrogen. So this rule states that this bromine will add on to this and we will get this product, that is CH3 CH Br, and this H will combine with H2 and we will get this. So this is bromopropane. Now we have to explain the mechanism of this reaction. Please always remember the negative part will add on to that carbon which has lesser number of hydrogen atom. This carbon has 2 hydrogen atom, but this carbon has 1 hydrogen atom. So this carbon has lesser number of hydrogen atom. So the negative part, that is the bromine, will add to this and we'll get this product. So let's now try to find out how does this reaction occur. Okay, so the first step is generation of electrophile. How does this occur? We have HBr with us. So what will happen? This HBr, step 1, this is step 1, HBr will dissociate by heterolysis and we'll get H plus and Br minus. So this is the electrophile. Now in the second step, step 2, what will happen? We have to take propene, that is addition of electrophile. Second step, addition of electrophile to the alkene molecule. Addition of electrophile to the alkene molecule. Here the alkene is propene. So propene, that is CH3 CH double bond CH2. Now what happens? Propene, there is a pi bond, so pi electron, negative charge. So this will come here, this H plus, and it will attack on this molecule. Now what happens? Pi electron, they are weak the pi bond is a weak bond, so this can move around and H plus can come and attack at this position. Now what happen if this comes and attack at this position? Then there is 2 route by which this reaction can occur. So what are those 2 routes? Suppose This pi electron moves here. So what will happen? A negative charge will be developed here and positive charge will be developed here. One possibility is this, root 1. Let's see first root 1. So this will come and attack here, and we will get a carbocation like this. This is a secondary carbocation. Now suppose root 2. What is root 2? Root 2 is that this CH3 CH double bond CH2, this pi electron, instead of moving to right side, if it moves to left side, then what will happen? Let me use a red pen. Then if it comes here, then minus charge will be developed here and plus charge will be developed. This pi electron come here, so plus charge will be developed here, and so the H plus ion can come and attack this at this position. So we will get CH3, CH2 and CH2 plus. The carbocation, this is a primary carbocation. Okay, now among carbocations are of 3 types: primary, secondary, tertiary, but the order of stability is tertiary carbocation is more stable than secondary and then primary. So the reaction will follow this path in third step and not this one. So this is the preferred route and not this route, because in this case secondary carbocation is generated which is more stable. Why is more stable? You can see there is 2-methyl group. Okay, so by inductive effect they will stabilize this carbocation, or plus I effect. So in the third step what will happen? So let's move rub root 2. Now this is, we have come to know that root 1 is the correct one. So the third step is what? In the third step the bromide ion will attack to give the product. Attack of Br minus on the carbocation to give the product. Okay, so we will write this one. We will take this CH3 CH3, you already know plus charge is there, so bromide ion, it is minus, it can easily come and attack at this position, and we get the product as stated by Mr. Markovnikov. Okay, so this is the reaction mechanism of Markovnikov's rule. Please go through these steps, try to understand why root 1 is preferred one, and then we should take why should we take root 1 for, so that we can carry out the third step. So that's all.